What lesson are we doing now?
Lesson 2!
The guiding question is, wants to read it? Go ahead.
What are some technologies ocean engineers have designed to help scientists study the ocean floor, and how are these technologies useful?
Let's just talk about it. Who wants to tell me? Taylor.
Submarines.
Submarines are awesome. I love submarines. Yes?
Submersibles.
Submersibles, great word. All right, so what we're going to do is we're going to use an older technology. Here is my sounding pole. Now the sounding pole's technology was used to try and figure out what the bottom of the ocean looked like. And why might that be important? Why do we need to know, or why should we look to see what the bottom of the ocean looks like?
If the bottom of the ocean, it's very dark and cold, so they couldn't really see if they had that, so that's why they need to send something down.
They need to send something down, but also to think about ships going by the oceans. A lot of reasons why they came up with the sounding pole is because they had to figure out if ships were going to hit anything, if there was anything that's sticking up, jagged rocks or things like that. What I'm going to do is I'm going to hand this out. If you look at the piece of paper you have here, the sounding pole right here has all the numbers on it, 1 up to 7. And we said that this is the deepest part of the ocean and this is the lightest part. So Taylor said we're going to turn 1 black. So Taylor is now coloring the sounding pole black, and you guys can change number 1 to black. So what's next? What's number 2? What color should it be? Yes?
It should be like a grayish color.
Gray works. Okay, so let's go for number 2 is going to be gray. Number 7?
7 is light blue.
Light blue. All right, while we're coloring in our sounding pole, let's take a look at the technology and how it's used. Our model of the sounding pole isn't the real sounding pole because the ocean is so much deeper. This is pretending our boat is this big, and we're this big, and we're floating on the model of the boat, and we put the sounding pole down to try and get the depth of the ocean. Now you guys should have a sheet of paper that looks like this. The depth data grid. Everyone say depth. Data. Grid. So you guys have done grids, right? You know that A1 is a coordinate, A2 is a coordinate. So we're going to take the coordinate and then we're going to draw it on our paper. All right, so everyone records the number depth of the ocean by noting the number and the color. So not just the color, but also the number. If it's a 7, you put 7 light blue. So this will give us the evidence we need to tell us what the bottom of the ocean looks like. All right, so I'm going to come over to our model ocean and I'm going to look for A1, and I take it like this. I push it into the box, and I push down. So if the A1 is 7, what do you do as a group? Chase?
If A1 is 7, then like in the A1, then you would write light blue.
So we're looking for the light blue. Send me an ambassador from your team. So what are we at? What do you think? Is that a 6? All right, so we're going to give 4 a 6. B1. There it is. Go straight down. And where are we at? 7. 7. B1. She's going to call it a 7. B9 is 7. 7 again. There's a lot of 7s. But that is still data. That data is telling us something. We have to interpret it later. All right, here we go. We have our last row. Does everyone think, what does everyone think the last row is going to be?
7.
Everyone? Does anyone think there's going to be something else besides a 7?
Nope.
A couple of you. Okay, so we're about 50-50. All right, so now, let's take a look at this. Brendan, do you know where things are at the bottom of the ocean by your data?
Yes.
Can you tell me where it is?
Right here, A2.
What's that? A2? Is that right? Who says A2?
Me.
Yeah.
Okay, very good. Go ahead. Where else?
A4.
A4. Where else?
A6.
So our data is telling us if the number has changed, something has changed on the bottom of the ocean. So that means what? If there's a 6 there, what does it mean?
It means that there is something on the bottom.
There's something there. Can you identify where the shallow areas are and the deep areas? Where are the deepest areas? What can we say the number is the deepest area? 7. So 7s are our deepest. So then the shallowest area of the ocean? Harper. 6. Exactly right. That was the shallowest, which isn't much more shallow than our 7s. Okay? So how many things have we identified are on the bottom of the ocean? Can you see it? Yes?
8.
Why did you say 8?
Because there's 8 objects on the bottom of the ocean.
Very good job, guys. All right, so what are some of the advantages of using this technology? Yes?
It shows how deep. It shows the deeper part of the ocean and the shallower part of the ocean.
Right, it shows parts of the ocean, right, that we just can't see. So we're able to put the sounding pole down there, and that's how this technology was formed. Okay, so what don't we know? Do we know everything about the bottom of the ocean? No. So tell me, what don't we know? Yes?
We're missing what is on the bottom.
What's on the bottom? Now, did we identify all the features? Who says yes? Who says no? If you said no, you're paying attention. Good work. Are you ready to see what's inside the box?
Yeah.
All right, so we're going to open it up, and we're going to see if we saw everything that was supposed to be seen on the bottom of the ocean. On the ocean floor, you will find ping pong balls and tennis balls, like always. No, of course, these are not ping pong balls and tennis balls. What are they? What do they represent?
They represent rocks.
So, did we see all of this on our chart? No, we missed almost everything that was on there. So, do you think the sounding pole is the best and only technology we should use for searching the bottom of the ocean? No, very good. Okay, so how can we improve it? You guys are now ocean engineers. Think about this. If you had only the pole to use and you're using it every day, you were like, man, this isn't working. I have no idea what's down there still. I'm wasting a lot of time. It takes a lot of work. What can we do to make it better? Yes?
We could, if you don't know what's down there, you could try to engineer, maybe put a camera on the bottom of the pole and then it will show you what's
Brilliant.
on the bottom.
What a great idea. Put a camera on the bottom of the pole, right? So these are really good ideas for coming up with ways to study the bottom of the ocean. But wait, if you think about it, Despina struggled with going down at a certain depth. And there is a point where scuba divers can't go because it does get too dangerous. Is there anything we can do to really study, to send stuff down and have it bring information back up? Yes?
Maybe we could sound the things that sound like the sound waves down. Then we could see how deep it was and see what points we could reach with the pole or what points we couldn't reach with the pole.
So you're saying send sound waves down?
Yeah.
Have you heard of this technology before?
Yeah.
What is it called?
I forget.
Anybody know the name?
Sonar.
Sonar! How much of the ocean have we studied?
50?
50%?
1%.
1%?
60.
60%, let me show you, right here. Can we keep the sonar beeping going for effect? If the entire room represents the entire ocean on the Earth, that corner that I'm shining the light on over there represents 5% of the ocean. We have only studied 5% of the entire oceans of the world. So that means there's a whole lot of work to be done and a whole lot of ocean to be discovered. In lesson 2 with the sounding pole, when talking to the kids, they really do love that part of the lesson. They love that they're collecting data and they're using technology, and we saw very clearly some of the problems that we had with the technology. When they were doing it, they were already like, oh, it's another 7, it's another 7. And so they saw the use of the technology, but they also saw clearly how it could be improved.